Hello students, in this video we are going to discuss some chemical reaction of carboxylic acid. That is, in this video we are going to discuss the acidity of carboxylic acid. As we all know that the carboxylic acids are acidic in nature. So the carboxylic acids, like alcohols, it evolve hydrogen when it react with the sodium metal. Just like the alcohols giving rise to hydrogen gas, it liberates hydrogen gas with the reaction with metal like sodium. Similarly, the carboxylic acid also react with the electropositive metals like sodium. It gives rise to hydrogen gas. That means when we do the test for carboxylic acid, the reaction is done with the sodium metal, that is an evolve of the gas hydrogen gas. And the carboxylic acid, it forms the salt when it reacts with alkalis like NaOH, similar to phenols. And they also react with the weaker bases such as carbonates like sodium carbonate and sodium hydrogen carbonate to evolve the carbon dioxide gases. So these reaction, that is the reaction of acid with the sodium metal, reaction with alkalis, reaction with the weak bases such as carbonates and hydrogen carbonates. So these are the very most important reaction or the test to detect the presence of carboxylic group, that is COOH. That is in the given compound, whether the carboxylic acid group is present or not, that can be easily identified by this test. That is the test. We using this test in the laboratory in order to identify the functional group COOH in the given organic compound. That is the reaction with the sodium metal giving rise to effervescence due to the formation of hydrogen gas, and reaction with the sodium bicarbonate, it also gives rise to effervescence, that is due to the formation of carbon dioxide. So these two experiments, these two tests, we are doing this in the laboratory in order to detect the presence of carboxylic acid group in the given organic compound. So this reaction shows the acidic nature of the carboxylic acids. So the acidic nature we can detect by these reactions. So the carboxylic acids actually dissociate in water to give resonance stabilized carboxylate ions and the hydronium ion. So this actually is because the carboxylic acid in water it dissociate. It dissociate means we know that the acids donate the proton. That means from here one H positive is donated to H2O. So that result in the formation of hydronium ion. We have learned already this in the previous classes. That is the acid base concept. So according to the Bronsted-Lowry concept, the acids donate the proton. That is RCOH is donating one H positive to water. So it forms hydronium ion, that is H3O plus, and there is a one formation of the carboxylate ion, that is RCOO negative is called as carboxylate ion plus H3O positive is formed. So this carboxylate ion, it get resonance stabilized. As you can see, it undergoes a resonance. So it gets stabilized by resonance. So when we make the equilibrium constant, because this is an equilibrium reaction, so what will be the equilibrium constant? Now that is can be represented in this way. Last we already learnt in the last year the equilibrium constant for this reaction, that is RCOOH plus H2 give rise to H3O plus RCOO negative. So that is the equilibrium constant we are writing for this equilibrium reaction, that is the concentration of product divided by concentration of reactant. Now what is on the product side? We have H3O plus on the product side, that is concentration of H3O plus, and we have RCOO negative on the product side, that is written here RCOO negative. And what is there in the reactant side? On the reactant side, we have here RCOOH, that is the concentration of this is taken and concentration of water is taken. But last year we have already learnt that the concentration of pure liquid can be taken as a constant. So better we will rewrite this equation in this way, that is the equilibrium constant and the concentration of water, that is also constant. So together we'll take a new constant that is represented as Ka. Here the Ka is called as a acid dissociation constant, and what is KEQ? That is the equilibrium constant. So Ka is the acid dissociation constant, or we can say that dissociation constant of the acid. So depending upon the value of Ka, we can say that the strength of the acid can be determined as more strength or less strength. That is, greater the value of Ka, greater will be the acidic strength. And we know that when we take the negative log of Ka, that is giving rise to pKa. That is, negative log of Ka is equal to pKa. So here there is, if greater will be the value of Ka, lesser will be the value of pKa, because pK is the negative log of Ka. So the greater the value of pK for a given organic acid, we can say that lesser will be the acidic strength. So that is the most important point here. Greater the value of Ka, greater will be the acidic strength. But if greater the value of pKa, lesser will be the acidic strength, because what is the relation between Ka and pKa? That is, pKa is equal to the negative log of Ka. Because of that, if one is greater, the other value will be the lesser value. Next, we are going to discuss about the effect of substituents on the acidity of carboxylic acids. The substituents may affect the stability of the conjugate base, and thus it affects the acidity of carboxylic acids. If the substituents are electron donating group, that is attached to the carboxylic acid group, then the electron donating group destabilizes the carboxylate anion and weakens the acid. That means if there is a electron donating group, which we are representing here as EDG, that can be an alkyl group, alkoxy group, and so on. So if the electron donating group are there attached to the carboxylic acid group, it destabilizes the carboxylate ion, that is RCOO negative. It destabilizes the carboxylate ion. Because of this, it weakens the acid. That means the acidic character decreases when there is electron donating group like alkyl group or the alkoxy group. So because they are destabilizing the carboxylate ion, because of this, the acidity will be lesser. But if there is an electron withdrawing group that we are representing as EWG, that stabilizes the carboxylate anion and strengthens the acid. That means if there is an electron withdrawing group, the acidic character increases. If there is an electron donating group, then the acidic character decreases. So the electron withdrawing group increases the acidity of carboxylic acids by stabilizing the conjugate base through delocalization of negative charge by inductive effect, that is I effect, or by resonance effect, that is we are in short writing as R effect. So because of the presence of the substitute, it affects the acidity of carboxylic acid. So from this, what we can conclude that if there is an electron donating group attached to the carboxylic acid, then the acidic character decreases, and if there is electron withdrawing group, then the acidic character increases. Electron withdrawing group are nitro group and Cl, etc. So we'll take an example here, that is when we compare the acidic character of para-nitrobenzoic acid with benzoic acid and para-methoxybenzoic acid, which can also be named as 4-methoxybenzoic acid. So when you compare these three, in this there is a substitute here, that is a nitro group is a substitute here, and here there is a methoxy group, that is a substitute. Here the nitro group is an electron withdrawing group and the methoxy group is the electron donating group. So because of the presence of the substitute, that is electron donating group, acidic character decreases, and because of electron withdrawing group, the acidic character increases. So when we compare the pKa values, it is clear from this here the pKa value for 4-nitrobenzoic acid is lowest. That means they are more acidic, because pKa value is the negative log of Ka, and greater the Ka, lesser will be the pKa value. So here which one is the most acidic? That is the para-nitrobenzoic acid is more acidic because of the substitute, which is electron withdrawing group. But when we compare the acidic character of benzoic acid with 4-methoxybenzoic acid, in which methoxy group is an electron donating group, so the acidic character decreases. So that means these have lesser acidic character than the benzoic acid. So that means 4-methoxybenzoic acid have the highest pKa value. That means they have the lowest acidic character. It is one of the most important point which you need to remember whenever the values are given. So if pKa value is given to us, so greatest the value of pKa, that is the lowest is the acidic character. That you need to remember. And if Ka value is given to us, then if greater is the value of Ka, greater is the acidic character. So that is important to remember when you are doing with such cases of examples or the problems. So the effect of substitute on the carboxylic acid can also be explained here. That is the effect of following groups are in this increasing order. That means CF3 greatest, then nitro, CN. So depending upon these group, here some of the examples are given. That is the following acids are arranged in the increasing order of acidity. That is shown here. So we can see that CF3 group, when it is attached to carboxylic acid, they have the highest acidic character, then CCl3, then CHCl2, then nitro group, and so on. Because here when you look at here CCl3, that means 3 number of chloro group, that is electro withdrawing group, so the acidic character increases. Similarly, here when you look at the case of this example, in this example there is a alkyl group, that is CH3, CH2 is an alkyl group, so acidic character is lower because it is electron donating group. But here benzoic acid C6H5, that is considered to be an electron withdrawing group because of the resonance. So we can say that it stabilizes the carboxylate ion, that is due to the delocalization of negative charge by the resonance effect. So they have a greater acidic character. So that's why they have greatest acidic character, and this have the lowest. So depending upon the electron donating group and electron withdrawing group, whenever any problems are given to arrange the increasing order of acidic character, so what is the most important point which you need to remember? If there is an electron withdrawing group, then the acidic character increases, and if there is an electron donating group, then the acidic character decreases. So you need to remember whichever groups are electron donating and which one is the electron withdrawing group. So you can easily arrange the given organic compound on the basis of acidic character. So this is all about, we have discussed about the acidic characters in the carboxylic acid, and the most important area here, you'll be getting question on this, that why this particular one is more acidic and why that is less. So that type of question will be discussing in the next video session. So this is all about this video. Have a nice day.